names. Okay, so to complete the square, don't forget you have to gather all the x's together, gather all the y's together. The only thing that wouldn't be stay on this side would be the plus 37 would go to this side. As you gather the x's together, I would have factored out the 9. As I gathered the y's together, I would have factored out the 4. The answer that you should have got is this. So today we've got something we're going to be looking at course selection here. We don't need to. So today we're going to have a little bit of a practice day, a bit of a slow day, and we're just looking at eccentricity really today. Eccentricity is a measure of how far from being a perfect circle a conic section is. I wish I could copy this across. This is a 3-dimensional cone, and when we cut it perfectly across horizontally, the cross-sectional area would be a perfect circle. If we cut it at a slight angle, we get a circle that's slightly stretched in one direction. And if we cut it at a steeper angle, we get that circle would be more and more distorted. If you cut it at a really steep angle, we'd get something that was way off being circular. Yeah? And then if you cut it at exactly parallel to this edge, you'd actually get a parabola. Okay, and we haven't gone on to ellipses yet. So eccentricity is a measure how far any of these curved shapes are away from being circular. Eccentricity is just a number that's anywhere from 0 to infinity. Obviously, the shape that is 0 distance from being a circle is a circle. This circle that I try to draw here, cutting directly horizontally across there, would have eccentricity equal to 0, because there's no distance between it and a circle. So a circle has got eccentricity of 1. The closer to 0 you are, the more perfectly circular the shape is. So this one might have, if you actually worked it out, I'm just guessing, maybe this one's got an eccentricity of about 0.2, maybe this one's got an eccentricity of about 0.5, this one would have an eccentricity maybe of about 0.9, okay? So there's just me guessing. Now an ellipse is always going to have an eccentricity that's somewhere between 0 and 1. When you get to a parabola, parabolas are really interesting. The eccentricity of any parabolas takes no work at all. If you get a parabola, its eccentricity is always going to be 1. Now the reason is, this is your equation to work out eccentricity, C divided by A. And I hope you remember that when I taught you about parabolas, we're calling this focal length at our school, we're calling it C. When you were the focal length, the distance from the focus to the vertex. When you were in Algebra 2, you probably called it P. We call it C, and I think I also mentioned that in some textbooks, they call it A. That's because they're all the same thing. So if C and A are the same, which is in every single parabola, they're the focal length, you're always going to have a number divided by itself. For a parabola, the eccentricity is always 1, and you never have to do any work. Look out for those questions on a quiz or a test. They're a gift. We haven't done hyperbolas yet, but they still have some curvature, but their eccentricity is going to be greater than 1. And a straight line, how much curvature is there in a straight line? Well, none at all. So how far away from it is it from being a circle? As far as you can get. A line has got an eccentricity of infinity because it's got no curvature at all. Okay, so remember that eccentricity is a number between 0 and infinity, and you don't need to, this one's worth memorizing. This one you just use to check when you calculated the eccentricity of ellipse, just check that your final answer really is somewhere between 0 and 1. And when we got onto hyperbolas, you'd check that your final answer was a value that was bigger than 1. Okay, so that's all we need these notes for. Let's just dive in and try an example. Now, I have to be careful. I often end up writing A over C. Think of the C, think about your crown goes on the top. Yeah, crown goes on the top, put the C on the top. So, oh, there's a practical application of in the real world of eccentricity. Apparently, opticians use it to work out how out of round your eyes are, and it helps them to work out if you're long-sighted or short-sighted, what the focal length is of your eye, and how to adjust it using lenses. We're not going to go through this, but they actually do. They compare the length of your eyeball to the height by some of the measurements they take. It can help them sort of guess in advance what sort of glasses you'll need. Okay, so let's have a look at this one. Determine the eccentricity of this ellipse. So to work out the eccentricity, think of the crown goes on the top. We're going to need the C divided by A. We don't have those, none of those are the numbers that are in this equation. We do know, though, that we would know from the equation what A squared was. We would know what B squared was. So that would give us C squared. And then you can actually work out the eccentricity. Okay, try your best and think about how you would simplify your answer. I'm giving you a minute. Off you go. So on this one, our A squared is your bigger denominator, so it's this one. Our B squared is our smaller denominator, so it's this. Subtract those. You get 25. So A is the square root of 64, which is 8. C is the square root of 25, which is 5. So C goes on top. Wonderful answer. Definitely smaller than 1, because the numerator is smaller than the denominator. Now, in pre-calculus, we often love things as fractions, and there's nothing wrong with this. But don't forget, there is another form. There is another way to write this. And if they are easy fractions like this, we might give it to you. What's another way to write this? It could be written as in decimal form. Both of those answers are right. Okay, now we don't tend to want decimals. That one I hope you remember from middle school math. But if you need to pick up a calculator to work out the decimal, your answer's wrong. Remember that we don't want you to use calculators, so most of the time we're going to want a fraction. But if you got something like 3/4, we hope you'd recognize that would be 0.75. Or if you've got a half, we hope you'd recognize that could be written as 0.5. Okay? Right. So try another one. Try this one. This is from your homework. This is number 4 from your homework. See how much of that information you can fill in and think about how you could simplify your answer. So I'm going to give you a little bit longer on this one. Okay, try this one. It's number 4 from the homework. So on this one, the type of conic, I hope when you look at it, you can immediately tell this is an ellipse. You need to fill this information in on that worksheet, your homework. Its orientation, the bigger number is 33, it's bigger than 27, that's under the Y. So this one's going to have a vertical axis, major axis. You can just say it's vertical, or you can say a vertical major axis. Just say it's vertical, it's easier. The HK point on this, because it's if it was a parabola, that HK point would give you the vertex. But because it's an ellipse, it's going to give you the center, and the center of this one is going to be at -8 to +7. Now the eccentricity is going to be, we're going to have to work this out. So we've got A squared minus B squared will give you C squared. A squared is 33, B squared is 27, subtract those and you get 6. So your A is the square root of 33, C equals the square root of 6. So you're probably thinking your eccentricity is C goes on top. Now, when you go to enter your answers for your homework in, or if this was a multiple choice question on a test, that answer wouldn't be there. That's because this can be simplified. Now, we're getting to the point that we're not too fussy about leaving an irrational number in the denominator. That's not the problem. The reason this isn't a good answer yet is remember your rules for working with things like exponents, or these are with irrational numbers. If you had the square root of A and you are adding the square root of B, is it true that equals the square root of A plus B? No, not at all. That's absolutely not true. And neither does it work if you're doing a square root of A minus square root of B. When you're adding or subtracting, you can't bring them together. But if you're multiplying them, it does work. You can try that with numbers you know. That does work. You can bring those together. And often rules that work with multiplication also work with division. And this one certainly does. You can put those under one square root. So let's look at what we've got in our answer here. This can be simplified to be the square root of 6 over 33. And those numbers have both got a factor of 3. Who does this? I guess it's a Titsy. They've both got a factor of 3. So 3 goes into 6 twice and into 33 11 times. Now that would be a great answer in pre-calculus. We're very happy with that answer. Is it the best answer? No, it's not the best answer, but we're quite happy with it. That will be acceptable. Think about what you would have had to have done with that if you're in Algebra 2. In Algebra 2, you absolutely cannot leave an irrational number on the denominator. So you'd have to split that into the square root of 2, divided by the square root of 11, multiply top and bottom by the square root of 11, and you'd get the square root of 22 divided by 11. That's a better answer. And that's, you know, fully rationalize the denominator, all that sort of stuff. So in pre-cal, you can give me either that or that, but that's not good enough. Okay, it's not being reduced. Why I'm going through that with you is we're now actually finished with our lesson for the day, but through the rest of class, I want you working through the rest of that worksheet. Your homework is to finish anything you don't get finished in class. And then I'm not publishing a key for this. How you know you've got your answers right is you're going to have to go and put them into Canvas. There's an assignment called 7.2-2P Eccentricity Worksheet, whatever. And now you can go into that twice. It has a time limit on it, which is very generous, but it is a time limit. So finish the worksheet first, okay? Finish the worksheet first, then go and put your answers in, submit, and it will tell. And if you're, and most of it you don't have to type them in, it's just selecting from a list. But if your answer's not there, like if you were looking for the square root of 6 or the square root of 33, you are going to have enough time to try and simplify that. And this would be an answer. We've given you two together, saying we're happy with this or this. That'd be one choice in the drop-down list. They wouldn't both be there, okay? So you will have time, if you haven't fully simplified your answers, to go and look at them a bit more. When you submit it, you'll find out which ones you got right, which ones you got wrong. If you want to, you can go back into the assignment and do it for a second time to get a better score, okay? And I'm going to record your highest score from that. Now, please do this. It's only a homework grade, but on the back of the worksheet, you're going to graph you're going to graph an ellipse and graph a parabola, and you're going to see how you're going to have to enter your answers tomorrow when you take the quiz, and what you'd have to do when you're entering your answers on a test. So it's important to do it. Now, at the moment, I haven't published. The last two questions are in the form where you have to complete the square. And after you've completed the square, then you get to graph them. Well, if you can't complete the square properly, you can't do anything on the back. So in about 5–10 minutes, I'm actually going to publish what the answer, just what the equation should look like for 11 and 12 once you've actually completed the square. Okay? So that's your homework for tonight, and you have a quiz tomorrow.